Today, in this video, we're going to be looking at the vertex form of a quadratic equation. And of course, a quadratic equation has a graph that is a parabola. So here's the vertex form. And the vertex form, f of x equals a, and this is the same a that we've already seen in the standard form, times the quantity x minus h, quantity squared, plus k. So before we get into the bottom here, let's compare the vertex form to what you saw in the last video, which was given the standard quadratic form, f of x equals ax squared plus bx plus c. This form is just expanded where this form is factored. But as I said, the a is the same a that we have here. The a indicates a vertical stretch or shrink. And if a is negative, then the graph reflects over the x-axis, or you can just think of it as it just simply opens down. The h in this factored form is going to tell us a horizontal translation. And the easiest way to find that is to simply set whatever is inside of those parentheses equal to 0. And that tells you if you're moving to the right or to the left. The k indicates a horizontal translation. Now, if we compare that once again to this standard quadratic form, we don't have an h and a k in this one. But you did learn about the vertex formula. And you can find the vertex of a parabola by using the vertex formula. And the x-coordinate of a vertex is simply found by taking the opposite of b over 2 times a, and that gives you the x-coordinate. Obviously, if you want the y-coordinate, you simply need to plug in whatever that number is back into the function and evaluate the function when x equals whatever the x-coordinate is. The axis of symmetry for a parabola is also found by opposite of b over 2a. It's x equals something because the axis of symmetry is a vertical line. And a vertical line is always defined as x equals some number. So the x-coordinate of the vertex, x equals axis of symmetry, they are basically the same thing. Now, let's get into the notes that you were provided with for going over section 2.1. This is what they look like, and we're going to fill in a bunch of the blanks today. So this is the vertex form. This is what I just went over. Now the good news is the vertex in the vertex form is like boom, right in your face. It is hk. That's why I said take that x minus h and set it equal to 0 in order to find that x-coordinate of the vertex. Now, what do we have next? A 0 of a function. So let's take a look at that word 0, and it's got some synonyms that we can write in here. A 0 is the same thing as an x-intercept or a solution to the particular graph. It's basically, where does this graph cross the x-axis? That's what the 0 of a function is. Here's what it says in the wording here. It is a 0 of a function is an input value x that makes the output value f of x equal to 0. So wherever f of x equals 0, that is going to produce a 0 or an x-intercept. Let's look at 1a. For the function f of x equals 2 times x minus 3 squared plus 1, what are the values of a, h, and k? Well, let's write it again. So f of x equals 2 times x minus 3 squared plus 1. So our a value is right up front. The a value is a positive 2. And if that a value is positive, so a equals positive 2, we know that we are going to have a vertical stretch, like you learned about in chapter 1. And since a is positive, we know that this parabola is going to open upwards. Next, hk. So if we take x minus 3, set it equal to 0, we get x equals 3. And then, of course, So, whoop, lost my pen. This is my H and this is my K. We're always going to keep the sign that is in front of the K. But if we take this x minus 3, set it equal to 0, we see that the x-coordinate of the vertex is 3. The y-coordinate of the vertex is 1. That's why we're calling this vertex form, because we can see the vertex. So the vertex here is at 3, 1. Next, explain why the vertex of the graph, okay, I just did that. See explanation right there. If you estimate a 0 of a quadratic function from a graph, how could you use algebra to check your answer? Well, let's go backwards here. If f of x equals this, so let me write this down. So we're trying to find a 0 from the graph. Maybe we can't see it, but we do know the function is f of x equals 2 times x minus 3 squared plus 1. Remember what it said back in this paragraph. If we want to know how you can estimate the zeros, remember zeros are the same thing as x-intercepts, the zeros of a quadratic function, we just need to do this. So if f of x equals 0, let's replace this f of x with 0. So 0 equals 2 times x minus 3 squared plus 1. So from there, let's attempt to solve for x. That's why I said that zeros are also the same thing as solutions. So we're about to find the solutions when we let f of x, and remember f of x means exactly the same thing as y. They are interchangeable. So let's solve this equation. So let me just get that out of the way so I got a little more room. So if we have 0 equals 2 times x minus 3 squared plus 1, let's think back to algebra 1 here. Subtract 1 from both sides. We get negative 1 equals 2 times x minus 3 squared. And then let's divide by 2, and now we've got an equation here. Let's keep thinking about it. Expand my paper here. So now we've got those canceling. So negative 1/2 equals x minus 3 squared. What? If we take a look at this, if I want to undo the square here, square root, the square root undoes the square. That's going to open up that x minus 3. But think back to algebra 1 here. Can I take the square root of a negative number? Does that exist? That is going to take us to a whole new place. So let's go and let's use what you learned in the last video, and let's take this function and try to estimate those zeros again. So I'm going to rewrite this function here on my graph paper. F of x equals 2 times x minus 3 squared plus 1. Now we already know that the vertex is at 3, 1, so I'm going to plot that point over 3, up 1. We know that the axis of symmetry is going right through that vertex. We also know that our A value is positive 2. That's going to create a vertical stretch. So it's going to make it taller and skinnier. So let's make a little table of values here. And remember the whole idea of the axis of symmetry, that it would not make a lot of sense to like plug in values over here because that's going to be way off the graph. If we know that this is the middle of the graph, it makes sense to plug in 2, it makes sense to plug in 1, and it makes sense to plug in 0. That way we can plot some points on this left-hand side of the graph, and then we can find some corresponding dependent y values. So let's do that. And so let's plug in the 2. So f of 2 equals 2 times 2 minus 3 squared plus 1. Follow order of operations here, and let's simplify this. This is 2 times 2 minus 3 is negative 1. Negative 1 squared is 1, so 2 times 1 plus 1, that is 2 plus 1, that is 3. So when x is 2, y is 3. So over 2, up 3. We're already seeing how this parabola is going to be tall and skinny. Let's plug in the 1. Using substitution, let's find the value of f of 1. That's 2 times 1 minus 3 squared plus 1. That's 2 times negative 2 squared plus 1. 2 squared is 4. 2 times 4 is 8. 8 plus 1 is 9. So over 1 up 9. We are already almost off the graph. I don't even think we're even going to be able to plug that in and graph it. We can plug it in. We can find that evaluation. It's just not going to be on our graph. 2 times 0 minus 3. So that is negative 3 squared is 9. 2 times 9 plus 1. That is 8. That is 19. Not going to fit on our graph. So we got a tall, skinny parabola here. So axis of symmetry, whatever's on the left is going to be mirrored on the right. So we have a point there. We have a point here. So here's what the graph. So take a look. Why were we unable to find some x-intercepts? Because there aren't any. If our parabola opens upward and it has a vertex above the x-axis, is it even possible for us to estimate any zeros here? No, it is not, because they do not exist within the real number system. To the back, let's look at example 2. Example 2 at the top, graph the function 2 times x plus 1 squared minus 2. Identify the vertex, minimum or maximum values, axis of symmetry, and the zeros of the function. So, in a parabola, the max or the min is simply going to be the vertex. Max or min is either going to be the vertex. And of course, the zeros, once again, those are the x-intercepts if they exist. So look at what's given, and let's find the vertex. There's h, there's k. Remember to find h, set that x plus 1 equal to 0, x equals negative 1. And k, you keep it the same, it's negative 2. The vertex of this graph is at negative 1, negative 2. So I am going to use my handy ruler, and I am going to first realize that I'm going to be opening up because the a value is positive 2. This is going to be a tall, skinny graph again. My vertex is back 1, down 2, so I am going to give, trying to think of the best spot to put my axes in here and put my axis, let's see, how about there? That's going to give me a good amount of room. Back 1, down 2. There's my vertex. There's my vertex. Back 1, down 2. Negative 1, negative 2. That means my axis of symmetry is running right through the middle of that vertex. So axis of symmetry, remember the axis of symmetry is the same thing as the x-coordinate. Usually we just say AOS. That's a quick way to identify that. X equals negative 1. So now let's fill in this table of values and let's find some more coordinates. So here's 0, negative 2, negative 3, negative 4. So let's plug in the negative 3 here. So f of negative 3, f of negative 3 is 2 times negative 3 plus 1 squared minus 2. Negative 3 plus 1 is negative 2. Negative 2 squared is 4. 4 times 2 is 8. 8 minus 2 is 6. So at negative 3, we are up 6. 1, 2, 3, 4, 5, 6. So back negative 3, up 6. Remember, this is a tall, skinny parabola. At negative 2, f of negative 2. That's 2 times negative 2 plus 1 squared minus 2. Negative 2 plus 1 is negative 1. Negative 1 squared is 1. 1 times 2 is 2. 2 minus 2 is 0. Back to up 0. We just found an x-intercept. 0. When x equals 0, that allows us to find the y-intercepts of the graph. What is f of 0? F of 0. 2 times 0 plus 1 squared minus 2. 1 squared is 1 times 2 is 2. 2 minus 2 is 0. That is another 0, which makes sense because of symmetry. If there's one point to the right of the, or to the left of the axis of symmetry, there will also be one to the right. Now, if we plug in 1, we can extrapolate that we are also going to be up at 6 by using symmetry. So that is what your point looks like. We graphed our points. We connected them with a smooth curve, as smooth as I can be. Maximum or minimum? We have a minimum value. The graph opens upward, so the function has a minimum. The minimum is the vertex, and that minimum value is y equals -2. Or you can think of it as a point. The minimum is at -1, -2, which again is the vertex. The axis of symmetry, we already said it, it's x equals -1. And the zeros are at the points -2, 0 and 0, 0. So the zeros of the function there, we got it. The zeros are -2 and 0. Now, let's take a look at what you can continue to do to be ready for the rest of this lesson. I would love for you to look through number 3 and try to fill in those, and we can talk about those in class or hopefully when Miss McGuire returns. Again, writing equations, it's the same thing. You're just filling in information, but you're just going backwards, being given the graph, and you're going backwards and building the equation. I'll see you in class.